Hello everyone. So this is a question from JEE Advanced 2025 paper 2. The density in gram per centimeter cube of the metal which forms a cubic close packed lattice, CCP lattice, important, with an axial distance or edge length of 400 picometer. Okay. And they have given us the atomic mass of the metal is 105.6 U and Avogadro's constant as 6 into 10 to the power 23 mole inverse. So we will underline the important points, that is, we have to calculate the density. They have given us a CCP lattice and axial distance is given to us. It is 400 picometer. Atomic mass of metal is given to us and Avogadro's constant is given to us. The chapters involved is solid state, which is exclusive to JEE Advanced. Okay. So to solve this, we have to talk about cubic close packing. The most important point is that it is similar to FCC packing or the face centered packing. Okay, so I will write this point down, that CCP packing is similar to FCC or face centered cubic packing. Okay, and we know that FCC has 8 atoms on the corners and 6 atoms on the faces. So whether I say CCP or whether I say FCC, they're the same thing. So both of them, they contain 8 atoms on the corners and 6 atoms on the faces. Okay, and obviously one on each face, since there are total 6 atoms on the faces and 6 faces in a cube, so we have 1 atom each on each face. Okay, so representing that by a diagram, so I will draw a cube. So 8 atoms on the corners, 1 2 3 4 5 6 7 8, and 6 atoms on the face center, so 1 2 3 4 5 and 6, right? So this is, the FCC crystal. Now next we have to calculate the contribution of atoms present at different lattice sites. Okay, our next task is to calculate contribution of atoms present at different lattice sites. An atom which is present at the corner, for example these guys, they are shared by 8 unit cells, very important. An atom at the corner is shared by 8 unit cells. Okay, so representing that by a diagram, so I will draw the diagram of cubes. Yeah, so let's say this is an atom, which is present at the corner. So can you see this guy is shared by this unit cell, this unit cell, this unit cell, this unit cell, this one, this one, this one, and this one. So there are total 8. 1 2 3 4 5 6 7 8. So 8 of the unit cells are sharing the corner atom, right? So contribution of each atom present at the corner will be 1 by 8. So therefore contribution of each atom present at the corner will be equal to 1 by 8 because 8 of the cubes are sharing the same atom. Okay. Next, an atom on the face is shared between two unit cells. An atom on the face is shared between two unit cells. Okay, for example, if you see the diagram, so let's say we have a atom on the face here. So can you see this guy is being shared by both this unit cell as well as this unit cell, right? So therefore contribution of each atom on the face will be 1 by 2. Right. So in CCP or FCC, because that's what is given to us in the question. So we have, as we have discussed, 8 atoms on the corners and 6 atoms on the face. So what will be the total contribution? So we have to calculate. So don't forget, our aim is to calculate contribution of atoms present at different lattice sites. Okay. So we are calculating for our CCP or FCC crystal. Since there are total 8 atoms on the corner, so contribution by atoms on the corner, contribution by atoms on the corner will be obviously one guy, one atom in the corner's contribution is 1 by 8, and there are total 8 atoms on the corner, so it will be 1. Similarly, contribution by atoms on the faces. So we know that there are total 6 atoms on the face, right? And contribution of each is 1 by 2 because one face atom is shared by 2 units. So it is 1 by 2 into 6. So it is going to be 3. Therefore, the total number of atoms present in the unit cell is actually 4. So that is equal to 4, right? And so now we know the edge length and the type of crystal structure. We can easily calculate the density of the crystal. Okay. So it is given to us in the question that the edge length of unit cell is edge length is 400 picometer, and number of atoms present per unit cell, we just calculated, it is 4. Number of atoms per unit cell, it is equal to 4, right? Atomic mass of the metal is given to us. That is equal to 105.6 U or AMU, both are the same thing. So density of unit cell is obviously mass of the unit cell divided by volume of the unit cell, right? Cool. Now we know that unit cell is a cube. Any unit cell is a cube, right? Face centered cubic, right? So it's a cube, and volume of a cube is a cube, where a is its edge length, right? So let us say that we have a cube and the edge length, let's say this, is given to us as a. So what will be the volume of this cube? A cube, right? So in our case, the volume of unit cell will be, so volume of unit cell will be, obviously the edge length is given to us that it is 400 picometer. So the volume of unit cell will be 400 picometer to the power 3, right? Since there is one important catch here, the catch is that in the question they have mentioned we have to calculate density in gram per centimeter cube. So be careful of the units also. So therefore I will convert this picometer into centimeter, and we know that 1 picometer is 10 to the power minus 12 meter, and 1 meter is 100 centimeters, so 10 to the power minus 10 centimeter. So this is the relation between picometer and centimeter, right? So therefore we can write volume of unit cell will be equal to 400 into 10 to the power minus 10 centimeter whole cube, or upon expanding it will be 400 cube into 10 to the power minus 30 centimeter cube. So we have calculated the volume of unit cell. Next we have to calculate the mass of unit cell. So mass of unit cell will be equal to, it's very easy, total number of atoms in the unit cell into mass of each atom, right? Number of atoms in unit cell into mass of each atom. And we know that since it is a FCC or CCP, so total number of atoms we have already calculated, it is 4, and mass of each atom is given to us, that is 105.6 U, right? Okay, one more catch is, again they're asking us density in gram per centimeter cube, and here the unit of mass is U. So we have to convert U to grams, and we know that 1 U is equal to 1 by Na grams. This is very important to remember. Okay, and Na is given to us in the question, that they have told us to take it as 6 into 10 power 23. Okay, so therefore mass will be actually 4 into 105.6 divided by 6 into 10 power 23 grams. So this is the mass of the unit cell, right? So therefore density of the unit cell will be equal to mass divided by the volume. So 4 into 105.6 divided by 6 into 10 power 23, and volume we have already calculated, that is 400 cube into 10 to the power minus 30 gram divided by centimeter cubes. So we'll be getting the final answer in gram per centimeter cube, right? So to do this calculation, we can write 400 cube as 400 into 400 into 400. Now 10 power 23, 24, 25. This is 10 power 23, 24, 25, 26, 27, 28, 29, and 10 power minus 30, that is 10 power minus 1. So 10 goes to the denominator. So into 10 goes to the denominator. This is, we have done that calculation. So in the numerator, we are left with 4 into 1056 divided by 6 into 4 into 4 into 4. This 4 gets cancelled. And when you do this division, 1056 by 6 into 4 into 4, it is exactly divisible. And you will ultimately get your answer as 11 gram per centimeter cube. So this is the density of the unit cell. Okay. So therefore, our final answer is 11 gram per centimeter cube. So it is 11 gram per centimeter cube. Okay. Thank you.